That's
This
rough.
guy did the same thing actually. He also
Okay, here's the explanation. They said, first of all, find the second derivative in terms of x and y. That means there's a period there, so I'm going to stop and do that much. So to find the second derivative, we do d dx of this half. That creates this symbol. Anyone have a question so far?
Oh, is that for the problem above? Oh, okay.
No, I'm an idiot.
Like, literally, why is this one?
Yep. So I do d dx of this, and d dx of this becomes this.
Oh, so you're finding the double derivative.
I'm finding the double derivative. That means I've got to do d dx of this, so the video can hear, don't talk. I got to do d dx of 2x minus y. Well, d dx of 2x is going to be just 2, and the y is going to become dy dx.
Did I not get that?
So pause there. Anyone have a question to that point? Okay, now, I missed this point the first time I did this problem years ago because I stopped. I wasn't as careful as I should have been. It said in terms of x and y. That means I can't be writing dy dx. I've got to put back in what dy dx is.
Oh my goodness.
Oh, that is tricky.
Tricky.
So that's where it got me. I won't lie.
Oh, it got me.
When
It
it
got me.
said in terms of X and Y, I didn't know what that
I didn't know what to
was.
do either.
Yeah, it got me.
So whenever it says in terms
They
of
are
X
so
and
close,
Y,
though.
you
A for effort.
That's
will it ever say that if it doesn't?
I've seen this many times over the years. This statement right here. I've seen that on many AP tests. So now I've learned my lesson. I got to keep going. It's only one more step. It's not a hard step. You just have to remember to do it.
That's just me.
So the yellow box is 1 point. There's no way to get part of that. They can distribute, I guess. If they distribute, it's fine, but otherwise, that's it. That's how you get the 1 point. Other questions about the 1 point?
So just having y prime is not.
It's not. Stop too soon. No point for stopping too soon. That's what I did wrong.
That's what he's saying. So they made it.
I was like, I did.
Let's say they got that far, but they actually put the negative. They distributed the negative.
If you distribute the negative correctly, you're fine.
Yeah, that's correct.
So they have this. They have the second derivative of y with respect to x is equal to 2. Subtract 2x plus y.
Yes.
That would be worth a point.
That's my favorite answer.
So this green box is also the same as the yellow. So, yep.
So there's d squared y.
They were just imagining putting lots of days wrong.
This is my favorite answer thus far, so I decided to add.
What is this?
What?
Coconut tree.
Someone drew a palm
pirate
tree with
ship
like
or
a pirate
something.
ship.
Yes.
Favorite answer.
So on their explanation, it says the concavity of all solutions is concave opposite.
They wrote
It's positive.
And they got the answer wrong.
Let's wait on that. Let me
They didn't
explain
put
that.
any math.
Hey, I have not explained the red point yet, so hold on that one. Just, is it okay with the green?
What about instead of doing second derivative and then 2 minus that? Let's
No.
drop that part there.
Oh, that's, I would say no. Please,
Do they think 2 minus y prime?
It's pretty great.
say what? They could not. Yeah, that's right here, look.
I don't even know who you are, and I'm mad at you for not.
They created
Yeah,
their
they can't do
And this
that.
is out of
1 point.
no, but like the whole house.
The whole problem is out of 2.
Okay, sorry.
Yeah, the whole, you're good. The whole problem is out of 2.
Wait, just a minute.
You're good. Whole problem is out of 2.
I love that actually.
Okay, wait, that should be.
Okay, let me, hey, no one talk for a minute. No talking, so the video can hear better.
I don't know. I can't.
It says, give the concavity of all solution curves. Listen, the differential equation is this formula, the one that's in the y prime column of Danica's chart. The second derivative is this column of Danica's chart. So they're asking, the solution curve is this column of Danica's chart. That's the language. Does anyone need me to go through the language again? Just wave at me. So you just have to memorize the language. It's really what they're just assigning the words to. So the differential equation is this column of Danica's chart. It's the rate. We found the rate of the rate. That's the third column of Danica's chart. This thing they call the solution curve, that's first column of Danica's chart. And you have, there's nothing else I can do for you there other than to say that must be memorized.
So solution curves is the Y column?
The solution curve is the amount column. Yep. The reason it's curves is because when you find an antiderivative, you have the extra plus c, which could be a whole bunch of different numbers. So there are an infinite number of solution, like given a rate formula, there are an infinite number of solution formulas or amount formulas. Pretty good? Listen good. Okay. So it says, determine the concavity of the solution curve in quadrant 2. At this point, I'd be turning the page, man. That's just like bugging me. I'm going to do something else to get my points. They can have these. I don't care.
Yeah, facts.
No, it's true. That's how I take the test. I literally do. That's how I would take it. I'd say, I don't care about getting these points. Let me find something I can. This is more straightforward. But here's how it's done. In quadrant 2, every x coordinate is negative. Every y coordinate is positive. So I'm going to look at my formula right here and notice if I'm plugging in all x's that are always negative and y's that are always positive, guess what? My second derivative is always positive. So that's what I explained in red. So make your best judgment. If they, and this one I'm going to let you judge yourself. Like, if you need help, I'll come read it. Don't read it to me, it gets too long. But basically, you just judge whether they are saying what I just said. That because in quadrant 2, every x coordinate is negative, and in quadrant 2, every y coordinate is positive, therefore, the second derivative of the solution curve in quadrant 2 would always be positive, so the solution curve would always be concave up in quadrant 2.